negative 20 over 73, and that equals the absolute value of 20 over 73. All right, so let's take a look at this. Negative 20 over 73, and that equals the absolute value of 20 over 73. And they're asking if this is true or false. Okay. Now, the absolute value, what it does is it turns things positive in a sense. So the fact that it's already positive, I mean, this one's negative over here, that these two things are equal. And we know that no negative is equal to a positive. So we're going to say that this thing is false. However, if it was the other way around, we would say that it's true. So if this problem happened to be this instead, remember the absolute value is around this fraction. So it just turns this one positive, which would be equal to this one. So this one would be true. Go from 8 to 1. 8 times 1 is 8. Now, because these two numbers are equal, that means that these fractions are equal. And always go from bottom up to top, and that'll tell you your value. If we had different numbers in there and we said, okay, we had 3/4, and we want to know its relationship to 1/8. Well, we'd still do that same thing. We'd go 4 times 1, which is 4. 8 times 3 is 24. So we know that this one is the greater number, which means this fraction is greater. All right, so we're looking at this number line. And we're supposed to plot -3, -5 over 2, -1, -1 over 2, and 0. Okay. One thing we can do when we're trying to figure out what this -5 over 2 is we can actually use our calculator. So what we can do, we know because this fraction's a negative, we can actually just divide 5 divided by 2 and see what that is. This gives us a decimal. So this is actually a -2.5. If we did the -1 over 2, we'd find that it is a -0.5. All right, let's plot these on our number line. Okay, so we know that this one's going to be at -3. We know this one was at -2.5, so we know there's a 2 and -3, so we know that it's halfway between these since it's -2.5, so it should be right there. We got -1, we know where that is. We know where -1/2 is. We said it's -0.5, so it's not quite 0, it's not quite 1 yet, it's right in between these. So let's put it right there, and then we got 0. Lots of negatives on this one. This one says to find the opposite of the integer. The opposite just means it's negative. If something was negative, it would be a positive. So this one is just -18. Okay, we both got two negative numbers. I like to think about these things. These are alligator mouths. The alligator wants to eat the bigger number. They're equal. They're just the same number, right? But when we're dealing with negatives, I like to think the opposite. Not so much that it's trying to eat 19 or 10, but these are the meals that this alligator is going to miss. So if we're thinking about it like that, would an alligator rather miss 10 meals, or would he rather miss 19 meals? Well, he'd rather miss as little meals as he can, right? So he wants to choose the -10. So -10 actually is the greater number. We got the negative absolute value of -42. We're looking at this thing, and so an absolute value makes things turn positive. We got a -42 in here. This negative still stays on the outside, but now this thing turns positive, so it's a 42 here, right? So it turned positive, but still that negative got applied to it, so it's still a -42. -33. It's the opposite of -33 is what a negative means. A negative, that's all it really means, is it's the opposite. If you're talking about 33, that's the opposite of 33. but this is the opposite of negative 33, which means that it's positive 33. These two things behave different. See how we had two negatives, but because one's absolute value and one is not, it's just parentheses, then it gives two different outputs or two different answers. So we got the absolute value of x, and that equals 86. When we're talking about absolute values, if we were trying to find the absolute value of 4, and we were also trying to find the absolute value of negative 4, let's look at those. Now, when we're thinking about absolute values, we're thinking about a measurement. If I had a ruler and I was measuring from this end to the paper to this end of the paper, I would say that it's 8.5 inches, right? Or 8.5 inches. If I turn that ruler around and I measured from this end to this end, just because I'm going to the left doesn't mean that it turns negative. Measurements are always positive, and that's the way we got to think about absolute values. Now, if we're counting how far away it is, we're going to say it's 1, 2, 3, 4. That gets us back to 0. And moving from here, we're going to measure here. 1, 2, 3, 4. So once again, this is 4 units away from it. Okay, and that's the way we think about absolute value. Now, looking at these two things, it gives us positive outputs. You'll find that no matter what you have in your absolute value, it just gives you the positive version of that number. If this is negative, it turns it positive. If it's positive, it stays positive. If we had a mystery number, we're going to call it x, and we said this gives us an answer of 4. And we're trying to guess what this mystery number is. That's all variables kind of really are, is just mystery numbers. We know that two things gave us an answer of 4, right? And we know that that was 4 and negative 4. So we could say that x has two solutions. So x could be that it is 4 or negative 4. Imagine that we had a different mystery number. We're going to call this mystery number y. And this one equals negative 2. Now remember, when we were talking about measurements, we measured this across. We didn't get negative 8.5, did we? Because measurements are always positive. So we're saying that the measurement of this mystery number gives us a value of negative 2, and that cannot happen. So we have to say that this has no solution. Now, there's one other option on here. There's one answer right here that will give us one solution. And the only thing that doesn't fit our criteria, remember a positive gives us two solutions, right? Oh, I didn't even write it. Yes, this gives us two solutions. And we know that a negative has no solutions. Now there's one number that only gives us one solution. And that number that's not positive or negative, that number is 0. That means that z, that mystery number, would have to be 0 to only give us one solution. We have the absolute value of x. This equals negative 68. Now it's asking if this has no solution, one solution, or two solutions. An absolute value yields a positive result. Now we have an absolute value that gives us a negative result. Anytime we have an absolute value that's given us a negative result, that is not even possible. Okay, so when we have that happen, we call this, we say that it has no solution. There is no number or value that we can assign as x that would give us this output. We couldn't put negative 68 in here. We couldn't put 68 in here. Nothing, because it would just keep giving us positive answers. The answer to this one is no solution. All right, so we're asked to classify the number, and we're trying to do negative 7. Let's look at a chart that I created that kind of helps us do this. This chart shows us where things are. We got 3 different main categories of numbers. We got real numbers, imaginary numbers, and undefined numbers. In this course, all we're going to be concerned with is real numbers. You'll learn about these. Actually, this will come up a little bit in this course, but imaginary numbers don't come into play until intermediate algebra. Let's look at the real numbers. The real numbers are divided into 2 different categories. That's why I put them in their own little box here, okay, and this in their own little box here. In this box, we have rational numbers. In this box, we have irrational numbers. The biggest difference in these is these cannot be expressed as a fraction. These have never-ending decimals, which makes it impossible for us to really write as a fraction. And this is another thing, that is never-ending decimals. You've noticed that when you write out pi that it doesn't end at 3.14, it just keeps on going on and on forever. If we put the square root of 2 in our calculator, it gives us this big long decimal, and it actually doesn't mean that the decimal ends. It means that it keeps on going on and on forever. And notice that these things don't have a pattern too. Okay, if they do have a pattern, it qualifies it to be a rational number. Okay, so you notice that this one keeps going on forever, but it repeats the 1 and the 3, so we can actually simulate an ending and put a bar over top of it. Decimals that do end, those are rational numbers. Just regular fractions are, even negative fractions. These could be negatives as well. And then we get into deeper categories. These are all still rational numbers, these numbers here, but these numbers are part of other smaller groups. Okay, once you get into the integers, okay, these are made up of all the exact numbers. These are -7, -62. By exact, I mean there's no decimal, there's no fraction that's extra with them. So they're just exact what they are. Okay, but they're also the positives, and it's 0 as well. Getting down deeper into a smaller category, the whole numbers are the exact positives, and they're 0. Okay, and then our natural numbers are the exact positives. Now remember, the number that we were looking for, I think it was a -7, wasn't it? It was a -7. I actually have this one listed on here. So this one would qualify right here as an integer. Now it's not belonging to these groups, but it's also part of the bigger group, which is rational numbers. For this one, we're going to say it's an integer and it's a rational number. Never will you choose that something is a rational number and an irrational number. These are two different groups. Keep that in mind. We were trying to figure out what the absolute value of x is that equals 86. So because this is positive, this has two solutions. And those two solutions are just the negative and the positive version of this number. So the two solutions are, so x could equal -86, which if we plugged it in there, it would give us that positive, or it could be positive 86. All right, we got a -6.3. Now, if we go back and look at our chart, we notice that this number does end, so we know it's not an irrational number. We know it's not an integer or a natural or whole number because these all deal with exact numbers. There's no decimals on these. So the only thing that this could possibly be is just a rational number. It's a decimal that ends, and it has a little bit extra on it. So we only have one classification that we can put that in. The absolute value of -41. Remember, absolute values just turn things positive, so that number just turns into 41. This one says if x is a whole number, then it is, and it's either always, sometimes, or never a natural number. So let's take x and let's plug him in our little chart. So it says that he is a whole number. So if he falls in right here, right? Now whole numbers actually take up all of this box. So it could be in this area or it could float into this area. So it means that sometimes if x ends up being, the mystery number ends up being a 0, then it's not a natural number. But if that x was represented by 5, then it is. So it looks like it's sometimes a natural number.